And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We see 0 sunspots. We're starting things out looking at the sun in colorized magnetogram. And it looks like those areas of magnetic organization have actually degraded in the southeast. Also, some interesting cosmology stories to cover today. We'll be talking about a Mongolian earthquake, coronal holes, and a neon white dwarf. And I hope the bandwidth is okay. It looks like we're seeing a little bit of weak bandwidth. I apologize if there are any hiccups in the internet connection. Let's take a look at what's going on at Lagrange point 5 at stereo A's coronagraph. And we finally see no coronal mass ejections to report. Still some possibility for additional ones, though, as we still see filaments suspended on the Earth-facing side of the sun. Again, that was the view from stereo A at Lagrange point 5. The radio flux of the 10.7 centimeter variety still at 73 solar flux units. There's the 1-year chart of that. Pretty weak radio flux there out of the outer solar corona. And for you new viewers, that's proportional to sunspot number. There you can see how similar those graphs are over cycle 24, the previous solar cycle. Let's just see if the bandwidth has cleared up. We've got pretty bad bandwidth here. And indeed, we don't want to purchase subscribers. Stop asking if we want to purchase subscribers. That's how you get muted for 10 minutes. Next, we're looking at the sun here in multiple wavelengths, 335, 193, and 94. And once again, the main activity is in the southern part of the sun. We see some filaments in the northwest. We'll show you close-ups in a moment on our fantastic HelioViewer movies. Here's 304 angstroms, and you can see that large filamentary system up in the northwest as well as down in the southeast. Here's the full disk view in 171 angstroms. And we'll save all the close-ups but one for the end of the video. Let that play through. And here's one of the close-ups. Allow me to vanish. And there's one of those filamentary regions there in the northwest, and an Earth scale to go along with it. All right, I certainly hope our bandwidth is doing okay here, as we see pretty weak internet connection, it looks like. Looks like we're seeing some lost frames. Let's hope it's working out okay. I don't want to have to redo the video. So in today's Smash Lights segment, I'd like to quickly bring up the fact that we've been censored by YouTube. We've had a video pulled down, and our brand new playlist, Smash Hole of the Week, is no longer a thing. So we'll put another video in there once we make another Smash Light of the Week segment. And so I'd invite you to visit our own sites, as we saw the writing on the wall long before the latest internet purge has happened. smAshomash.org, smAshomash.com. You'll find all of our social media links there. We're all over alt tech. Support us via our stores or perhaps becoming a patron. And our main store features shirts like the Mansa shirt, where we would invite you to make America not suck again. Smash staff and I both have a purple one. Yeah, make America not suck again. That is totally nonpartisan. I don't care what political party you're affiliated with, if any. Making America not suck again is up to you, not the government. Yes. Again, you can link to that straight from smAshomash.com, smAshomash.org. Pick up some merch. Are you safe yet? We're going to show you the video that got censored momentarily. First, I would invite everybody who's viewing the video to take a moment to press like and subscribe and the notification bell. Also, don't forget to press the share button and share the content on your social media. Tell your friends, your foes, your science noobs, and your science pros about the channel. Otherwise, they may not know. We did put up a community post, by the way, linking to the BitChute video, as the video taken down by YouTube is still on BitChute. And we didn't really say anything controversial. We didn't refute any of the WHO or CDC's pathetic guidelines. We simply stated facts, which apparently is no longer acceptable on the YouTube junkware, fraudware platform. Again, press like and subscribe on YouTube and share the content here, as we've got all kinds of exclusive content. We're hoping we can dance on the line of what we're allowed to and not allowed to talk about. Anyway, the video is called 300 Subscribers. Oh, that's not it. It's called Smash News Network Special Report, Smash Hole of the Week, and that's spelled W-E-A-K, as COVIDiots are pathetically weak. Here's a small clip from the video. You notice that? Also, check out our merch. You can find links below the videos to all of that stuff. The Teespring stores, for example, you can get yourself a Mansa shirt. The graphics are fantastic. And by the way, this is non-partisan. So anyway, check that out. It's at bitchute.com/smashomash. And we're going to go into a quick cosmology segment. Allow me to reappear here on the screen for you. Yeah, we're going to talk cosmology. And part of the reason why we cover the sun every day is because the sun is the Rosetta Stone of cosmology. So the first thing we're going to talk about is coronal holes. So here's one currently on the sun. And this is a one-day video of the southern hemisphere. You can see that large coronal hole region associated with the south polar region. And that's the main coronal hole to be currently associated with Earth, geo effects, and so on. You may find an article on phys.org today about coronal holes during the solar maximum. Now, the Hale cycle is one full polarity cycle. So 2 solar cycles are known as the Hale cycle, the 22-year solar cycle, where the poles fully do their full rotation. And this study shows a negative correlation between the numbers of equatorial coronal holes and active regions, as well as statistically significant differences in the properties of the 2 11-year cycles, perhaps caused by polarity. And we are interested in figuring out what causes the solar cycles to be a thing. Is it just some sort of physical properties within the sun? Is it its dusty environment? Is it some sort of external powering? Well, we certainly do not believe that it's from a nuclear dynamo in the sun's core, as we see a lot of nuclear activity on the surface. But in any case, the article examines changing differences and pairings between equatorial coronal holes and active regions, and they find more of the close pairings during the peak activity in one half of the cycle, but not the other. So why is that? Why is it that we see more coronal holes around the equator associated with active regions during the one half of the cycle, but not the other? I would say the most likely guess for that would be because of polarity. I've got no other theories on it, so I'm going to go with that one. Next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron, as we're paid almost nothing to make the videos on YouTube. Quite sure that we've been shadow banned for years, and barely at 1,700 subscribers here, despite doing these videos daily. Patreon.com/smashomash is, again, the true source of funding for the content. Thanks to our patrons for looking out for us. It helps us out a lot to know that there may be some income actually occurring as a result of the videos. And there's nothing random about becoming a patron. Again, patreon.com/smashomash. And today, we're not going to be rolling any dice to figure out what to talk about when it comes to cosmology. We're going to be talking about Cygnus X3, which is the brightest intrinsic object visible in the Milky Way galaxy from Earth. It's also a celestial pole star, which orbits. It swings around and around Polaris, the celestial north pole of the Earth. Deneb. And what do we see here? Well, we see the entire graph scale expanding here. So this is the 30-day graph. Let me just move that down. That's the 30-day graph there of the X-ray output of Cygnus X3, the massive X-ray binary consisting of a ultramassive object orbiting a Wolf-Rayet star in a period of 4.8 hours. So it's traveling at relativistic speeds, some significant percentage of light speed. And one of those jets is pointed directly at the Earth. Maybe that's why they built Göbekli Tepe to be facing the star Deneb, again, the most intrinsically bright object in the Milky Way galaxy. And we saw it go into a fairly stable state here. And now we see one of the strongest transients ever shown on the graph, all the way up at 0.3. Counts in the 15 to 50 kiloelectron volt range there. So you can see the graph has expanded here, and that is way off of this graph over here. It's way up here, way above the normal outputs. So that X-ray burst, perhaps something that should be studied further. We're trying to get radio astronomers to take a look at Cygnus X3, preferably as it comes out of its quiescent state into its X-ray loud state, which it is now solidly in over the past 30 days. You can see right there. And again, that graph has expanded because of an increased output of Cygnus X3, celestial pole star, at the other end of the quote precessional and quote cycle. Next, we're going to talk about this crazy record-breaking white dwarf system supernova remnant setup here. The green you see there is from spectral emissions of neon. So we see a neon oxygen white dwarf system here. And there's an article about this one on SciTech Daily. So it's a carbon monoxide / neon white dwarf merger. And this one has set some records, apparently, for the stellar wind output. So perhaps have a read about that one. SciTechDaily.com. And this is believed to be the result of two white dwarfs merging together in this supernoval remnant system. Just keep in mind, folks, that we've never seen a star born or die, which is why I take issue when I hear things about star-forming regions and so on. But apparently this one is pretty significant. And this is believed to be something that will, quote, collapse, and quote, into a neutron star within 10,000 years. It's very unstable. So perhaps have a read about that. Again, that's located at SciTech Daily, and you can find a link to the full paper down at the bottom of that article. And what else do we have to talk about at the Smash News Network? Nothing in terms of cosmology today, and that's today's cosmology segment. Next, we'll look at the real-time solar wind, and we saw earthly conditions rise into geomagnetic unrest for a significant period of time. And we almost did a video about it, not quite. We did see the BTBZ diverge from the zero line at the same moment that the phi angle shifted. And also we saw the solar wind density come all the way up to about 60 protons per cubic centimeter. There you can see about 60.5 protons per cubic centimeter there, a big increase in the solar wind density, followed by a drop down and an increase in the solar wind speed, which is still elevated here, around 470 kilometers per second right now. Solar wind density dropped down to 5.8. So solar wind speed around 470 kilometers a second, solar wind density around 6 protons. And that is a classic coronal hole wind stream. Expect this one to last a while, as we saw a huge density wave on the front of that one. And let's move on to more data. And there you can see that geomagnetic unrest lasted for a period of 15 solid hours there. So the better part of a day in geomagnetic unrest, a result of that coronal hole wind stream. Here's the magnetohydrodynamic pressure. Magnetohydrodynamic pressure. It's 4 hours of data courtesy University of Michigan. We show 4 hours daily, as this data is not visible in the archival form. Perhaps someday it will be. Here's what's going on with ground magnetic perturbations, and we see some significant magnetic perturbations, including some coming out of the Pacific Ocean, as well as out of the South Pole and both North Poles. You can see perturbations over the Siberian North Pole, which is somewhere around here, the Canadian North Pole, which is somewhere around here, which makes the net North Pole somewhere around here, and the South Pole is way over here. And yes, if it's a tic-tac-toe board, the X is just 1. Not to be confused with Cygnus X1. And let me just check the life of the stream here. I think the internet issues have been resolved. It is looking good. So let's move on to show you a flatlined proton flux as measured by the GO-16 at the F ionosphere layer around 300 kilometers altitude. No surprises there, as we don't see any major coronal mass ejections expected to strike. There's the X-ray flux over the past 3 days, also flatlined. No significant solar flares, sunspots, or active regions. And here we see a spiky GOES magnetometer, although the Earth is solidly in the South Pole current sheet. We'll show you on the next slide. And there is the ecliptic plane field plot, as if you're looking down at the sun's North Pole. And if you're wondering what these things are, that's stereo A at Lagrange point 5 and stereo B at L4. That's L4, that's L5. And this data is based on 51 ground-based magnetometers and magnetometers on those two stereo A and stereo B spacecraft. And so you can see here the Earth is solidly in the South Pole current sheet. Nothing to write home about there. And I would expect the Earth to remain there tomorrow. You can see its potential field surface source line there in orange in that red polarity zone. There's the last image. Keep in mind the data is about 1 hour and 21 minutes old and can change with absolutely no warning. Here's a different view of the same data set. Essentially, it's the line of sight coronal hole plot. And you can see a large coronal hole just moving into the Earth-facing zone here. It's the one we showed you in the section about coronal holes in 193 angstroms. So we should be expecting a significant coronal hole wind stream from that in about 3 days. And here's another plot of essentially the same data. It also shows you the poloidal fields in green and red. And it shows you a solar magnetogram as well. Weak activity from the sun in terms of radio output, sunspot number, X-ray flux, etc. But we've seen a solid week of lots of coronal mass ejections. It's part of the reason we have the channel. And we watch daily. We put up the data daily so you don't have to. And here's a magnetic field plot of the solar corona, the sun's atmosphere. A chaotic environment indeed. And let's move on to talk electrons. First, we'll look at a sky chart, not a scar chart. A scar chart, a sky chart. I use in-the-sky.org. And I draw in the ecliptic as I'm currently facing the south. And here's what's going on in the solar system. New moon tomorrow. There's where things will be in a week. I like to use the planetstoday.com. It's a nice, simple star chart to show our viewers on the daily. And thanks everybody who leaves comments, etc. Please don't attempt to sell us subscribers and views. We will mute you for 10 minutes. Don't spam. And here is the portion about electrons. And we see some minor charging hazards here over places like Mexico and the Central Pacific. There's the 1-year electron flux chart. That's courtesy solon.info/solar. And we're at low levels here. No surprise there. And the forecast is to continue at similar levels here, which does lead to more anomalies than at higher levels, more nominal levels. So we're at low levels of electron flux here. There's a 3-day chart of that. And all of that stuff is measured here at the F flare around the 300 kilometer altitude level at the GOES 16. And we just put that up daily to give our viewers an understanding of the way the electromagnetic radiation adsorbs into the atmosphere and where things are located. That is in kilometers. Next, we're going to look at a visualization of the electron content. We see major anomalies here over the North American continent. Significant GPS errors will be happening associated with that. I'll let it play through a second time so you can see those high-density electron flux regions. Yowzers. Some major GPS errors over the U.S. And that's showing you from about 12,500 miles where GPS satellites are located through the inner Van Allen belt, which is shown right here. That's the inner Van Allen belt. And that's just another graph there. Keep in mind, this is showing you altitudes in miles. Next, we're looking at the geoelectric field here. The empirical data. And you're looking at millivolts per kilometer here. And we indeed do see some induction, especially around the eastern seaboard area, following that period of geomagnetic unrest. And this was a little bit higher late night. I took a look at this earlier. It wasn't quite worth making a video about. We almost put out a video during the period of geomagnetic unrest, which has since subsided, although the solar wind remains slightly elevated. And before we move on to talk about power outages, it's time for me to vanish. And we see some power outages here over Louisiana and Texas. About 55,000 total custies out of power down there. And next we'll look at the ionosphere layer. So this is just the ionosphere layer, folks. One slice of the atmosphere around where the GOES 16 is making its measurements. And we see a pretty anomalous looking ionosphere here. Sudden charge ups over Central South America. As well as high charge zones down here at nighttime. And we've seen continued anomalies in the southern hemisphere. Don't believe me? Watch earlier daily space weather videos. We put it up daily. There's a whole playlist for it at youtube.com/smAshomash/playlists. Check out our other playlists as well. Anyway, here's the latest image, which is from 9:45 Universal Time. Again, a little bit anomalously charged up here in the southern hemisphere. You can see that blue blob making it up to 9 megahertz. Next, I'd like to know which volcanoes are erupting, so I cover it daily at volcanodiscovery.com. So, Kluchevskoy is producing a 20,000-foot ash plume. Dukono, 7,000-foot ash plume. Popocatépetl is Popocatépetl upticking? At the end of December 2020, daily volcanic tremor duration increased approximately 1,000 minutes per day, around which value it has been fluctuating during the past 2 weeks. The highest tremor reached 1,410 minutes on the 5th of January and can be seen in the attached diagram. I don't see a diagram. In any case, Popocatépetl remaining on the list. And it's been there for a long time. Fuego is also erupting in an explosive fashion and producing a 15,000-foot plume of ash. Sangay, 25,000-foot plume of ash as it explodes. Revenador, 14,500-foot ash plume above its caldera. It's exploding as well, and we see intermittent pulses of volcanic ash from Sabancaya. A reminder to not attempt to pole vault the caldera. Largest quake of the past 24 was a 6.7 magnitude west of Lake Baikal, located near the Russia-Mongolian border. And there is that 6.7 magnitude quake We'll just zoom out so you can see the location of that. North of the Gobi Desert. And let's get back to the list. That quake came in yesterday at 21:32 Universal Time. So 9:32 was the time of the largest quake in Universal Time. We see some deep quakes here, such as this 4.8 near Tonga. It's at over 470 kilometers depth. And what do we have here? There's one out near the North Atlantic Ocean, near the Mid-Atlantic Ridge. It's a 5.4 magnitude. There's one in India, a rare spot for an earthquake there, 5.1 magnitude. So some more deep quakes here, like a 4.6 at Tonga, a 4.4 at Indonesia. Vanuatu, a deep quake there. Again, there's that 6.7 at Mongolia, which came in at 21:32 Universal Time. 9:32 Universal Time yesterday. 9:32 p.m., that is. Another deep quake in Oceania. And we still see a drought of 7, 8, and 9 magnitude quakes, folks. A shockingly low number in the past couple of years. Looks like the second largest of the past 24 was a 5.9 at Japan, which was at depth, over 200 kilometers depth. Another deep quake in Indonesia. So significant deep quake event, an Afghanistan deep quake. And let's move on to look at the jet streams. Here are the jet streams of the Eastern world. A little more coherent than we've seen, although we do still see the jet stream blowing backwards, east to west, over the Western Pacific and Indian Oceans. Some significant speed there in the central Indian Ocean region. Next, how about the jet streams of the Western world? How about checking the life of the stream in the chat? Again, thanks to everybody who tunes in, whether you viewed live or you viewed the YouTube live premiere or you viewed later. Thanks for tuning in. We see some lightning here over the Caribbean, west and southwest of Cuba, and some in the Gulf of Mexico. Otherwise, no terrestrial lightning looks like is currently striking. And indeed, lightningmaps.org confirms no terrestrial lightning striking the U.S. Some in the northeastern Mediterranean region, though. And here's the U.S. Doppler radar map as we go briefly into the realm of meteorology. Some snow falling in northern New York and New England. Some fairly heavy rain in North and South Carolina, as well as rain and wintry mixes and probably some wet snow in the northern Rockies and the Pacific Northwest. Here's your snow forecast. It's the European snow forecast via windy.com. And there is where we expect to see snow at 12 noon Eastern Time tomorrow. Significant snow in Lubbock. Looks like 4 inches of snow expected to be on the ground tomorrow in Lubbock. Some significant snow events going on this year in Texas. It's snowing in Texas. Next, looking at the cloud layer. It's the 3.9 nanometer interactive weather satellite to show us clouds when it's too dark to see them with the visible satellite. Major low clouds over the Gulf of Mexico and western Atlantic. And we've got to redisplay our water vapor map here, folks. All right. So we see a band of dry mass of air here stretching all the way from the New Jersey coast all the way down to Baja California, really. So there's the water vapor and there's the cloud layer. And this should give anybody insight into what's going on if their Doppler radar is not helping. And if your Doppler radar is not helping, check out the NASA GOES interactive weather satellites. The water vapor map will set you free and allow you to forecast the weather, impress your friends, and frighten your foes. Speaking of frightening your foes, our bonus features aren't scary. So stay tuned for them. We're going to show you the solar intensity gram to show you 0 sunspots, I think, as well as a high-res image of the colorized magnetogram. And we would greatly appreciate it if it would load. That would be fantastic. We would be delighted. All right, so there is the colorized magnetogram, and you can see those areas of magnetic organization. There's one. That could be a sunspot. I see a pretty dark North Pole trailing region there. We'll take a closer look. Anyway, there's the colorized magnetogram. And it could be a sunspot forming once again. It looks a little dark right there. That is most likely that North Pole-oriented magnetic region. Otherwise, no sunspots. And quite weak output in general from the local yellow dwarf. So let's get back to our HelioViewer movies here and close this thing out. Once again, we'll re-show you that filament in the northwest. Great view of that in 171 angstroms. Here's the same area in 304 angstroms, ionized helium emission spectra. And it gives you a little bit more of a 3D insight into how that filament is sort of draped over the northwest limb there. Here's a filament that suddenly popped up in the southwest. We just kind of saw it on HelioViewer, so I just decided to make a screen grab of that. That's actually currently going on. You can see that filament pop up. And here's the area in the southeast. Large filamentary area there in 171 angstroms. And that's all she wrote. We are out of here. Thanks for tuning in. Remember, stare at the sun, don't drink, no matter how much the government drives you to drink. And if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Please visit our links. Help support the channel in any way you're able. Increase the probability these videos will continue to exist, remain publicly visible and free. And may that solar wind be at your back.